Siberia, a vast and icy expanse, holds many secrets. Spanning over 13 million square kilometers, it is one of the most remote and least understood regions on Earth. Its sheer size and isolation make it a place of wonder, where nature reigns supreme and humanity's footprint is minimal. It's a land of stark beauty and, well, unforgiving conditions. Temperatures can plummet to as low as -60 degrees Celsius, and the terrain is as challenging as it is breathtaking. Yet, this harshness has preserved its pristine wilderness, making it a treasure trove for explorers and scientists alike. Throughout history, Siberia has been a place of mystery and intrigue. From the ancient nomadic tribes who first called it home to the exiles and adventurers who braved its wilderness, Siberia's story is one of resilience and discovery. Its vastness has inspired countless legends and fueled the imagination of many. From ancient tales to modern scientific discoveries, Siberia continues to amaze us. Beneath its frozen surface lies a world of geological wonders, from permafrost that holds secrets of the past to vast reserves of natural gas and minerals that power the present. Among its most captivating enigmas are the explosive events that have shaken its remote corners. These phenomena, often violent and sudden, have left scars on the landscape and sparked debates in the scientific community. These events, often unpredictable and powerful, have left scientists and the public baffled. What causes these explosions? Are they natural, or could they be linked to something deeper, something hidden beneath the surface? The answers remain elusive, but the search for them continues. The Tunguska event, the emergence of massive craters, and the fiery trails of meteor explosions all point to a hidden energy beneath Siberia's frozen surface. The Tunguska explosion of 1908, for instance, flattened over 2,000 square kilometers of forest, yet no definitive cause has ever been confirmed. Was it a meteor, a comet, or something else entirely? These events not only reshape the landscape but also raise questions about the forces at play in this remote part of the world. They remind us of the Earth's raw power and the mysteries that still lie hidden, waiting to be uncovered. Siberia, with its icy grip and fiery secrets, remains a land of endless fascination. In 1908, a colossal explosion ripped through the air above the Tunguska River in Siberia. The event was so powerful that it was heard hundreds of miles away, and the shockwaves shattered windows and knocked people off their feet in nearby villages. Witnesses described a blinding flash of light, followed by a deafening roar that echoed across the wilderness. The event, now known as the Tunguska event, flattened trees over an area of 800 square miles. The sheer scale of the destruction was unprecedented, leaving a barren, desolate landscape where dense forest once stood. The force of the explosion was so immense that it is estimated to have released energy equivalent to 10 to 15 megatons of TNT. The blast was estimated to be thousands of times more powerful than the atomic bomb dropped on Hiroshima. It created a fireball that lit up the sky, and the heat from the explosion was felt miles away. The atmospheric effects were so intense that they were recorded as far away as Europe, where night skies glowed for days due to the scattering of light by particles in the upper atmosphere. Despite numerous expeditions and extensive research, the exact cause of the Tunguska event remains a mystery. Early theories ranged from volcanic eruptions to alien spacecraft, but none could fully explain the evidence. The remote location and harsh conditions of Siberia made it difficult for scientists to study the site until decades later. The most widely accepted theory is that a large meteoroid or comet fragment exploded in the atmosphere. This theory suggests that the object disintegrated before reaching the ground, releasing an enormous amount of energy in the process. The explosion would have been powerful enough to flatten trees and create the devastation observed. This airburst would explain the lack of an impact crater and the pattern of destruction observed on the ground. However, questions still linger. Why were no fragments of the object ever found? Could there be other forces at play? Over a century later, the Tunguska event continues to captivate scientists and spark the imagination of people around the world. In recent years, Siberia has witnessed the appearance of massive craters, seemingly out of nowhere. These craters, some stretching hundreds of feet wide and reaching depths of over 100 feet, have sparked both concern and curiosity. The leading explanation for these craters is the explosive release of methane gas. Methane, a potent greenhouse gas, is trapped beneath the permafrost, a layer of permanently frozen soil. As temperatures rise due to climate change, the permafrost thaws, releasing the trapped methane. This buildup of pressure eventually leads to a powerful eruption, creating the craters that have become synonymous with Siberia's volatile landscape. Methane is a powerful greenhouse gas, far more effective at trapping heat than carbon dioxide. The release of large quantities of methane from thawing permafrost has significant implications for the global climate. As temperatures rise, the rate of permafrost thaw is expected to increase. This positive feedback loop could lead to a runaway effect, accelerating climate change and further exacerbating the problem of methane release. Section 5: Celestial Fireworks, when meteors light up the Siberian sky. The vastness of Siberia, with its untouched wilderness and endless skies, makes it a perfect canvas for nature's most dramatic light shows. Here the heavens come alive in ways that are both breathtaking and humbling. Siberia, with its vast and sparsely populated expanse, is, well, a prime location for meteor sightings and impacts. The sheer size of this region means that meteors often go unnoticed by human eyes, but their effects can be felt for miles. The silence of the Siberian tundra is occasionally broken by the roar of a meteor streaking through the atmosphere, a reminder of the universe's raw power. The Earth's atmosphere acts like a shield, burning up most space debris before it even reaches the ground. This natural defense system ensures that countless meteors disintegrate harmlessly, creating dazzling streaks of light that we call shooting stars. But what happens when a meteor is too large to be completely destroyed? Well, larger objects can sometimes penetrate this defense, creating these spectacular fireballs and occasionally leaving their mark on the surface. These impacts can carve craters into the earth, scatter debris for miles, and even alter the landscape. In Siberia, such events are not just rare occurrences, they are part of the region's history. The Chelyabinsk meteor, which exploded over Russia in 2013, serves as a stark reminder of the destructive power of these celestial objects. The explosion released energy equivalent to about 500 kilotons of TNT, shattering windows and injuring over 1,000 people. It was a wake-up call for scientists and governments worldwide, highlighting the need for better monitoring of near-Earth objects. While most meteor events are harmless, the potential for larger impacts really underscores the importance of monitoring and understanding these cosmic threats. Astronomers around the world are constantly scanning the skies, tracking objects that could pose a danger to our planet. In Siberia, the night sky is not just a source of wonder, but also a reminder of our place in the cosmos and the need to protect our fragile world. Section 6. Climate change, a catalyst for catastrophe? Climate change is, well, a major factor influencing the frequency and intensity of explosive events in Siberia. Rising temperatures are accelerating permafrost thaw, leading to more frequent methane releases and the formation of craters. The warming climate also affects the jet stream, potentially altering the trajectory of meteors and increasing the likelihood of impacts in certain regions. The interplay between these factors highlights the complex and interconnected nature of Earth's systems. Section 7. The human element, our impact on a fragile environment. While natural phenomena play a significant role in Siberia's explosive events, human activities are also contributing to the problem. Deforestation, oil and gas exploration, and the construction of infrastructure all disrupt the delicate balance of the permafrost. These activities can accelerate permafrost thaw, increasing the risk of methane releases and other environmental hazards. It is crucial, really, to develop sustainable practices that minimize our impact on this fragile environment. Section 8. Siberia's unique susceptibility to explosive events. Several factors contribute to Siberia's susceptibility to explosive events. Its vast size and remote location make it a prime target for meteor impacts. The region's permafrost, rich in methane, is highly sensitive to temperature changes. Furthermore, Siberia's northern latitude makes it particularly vulnerable to the effects of climate change. These factors, combined with ongoing human activities, create a complex and potentially volatile environment. Section 9. Conclusion. Unraveling the mysteries, facing the future. Siberia's explosive mysteries serve as a reminder of the powerful forces at play on our planet. From the enigmatic Tunguska event to the ongoing threat of methane releases, these events challenge our understanding of the natural world. As we continue to explore and unravel these mysteries, it is crucial to acknowledge the role of climate change and human activity in shaping these events. By understanding the interconnectedness of Earth's systems, we can work towards mitigating risks and preserving the delicate balance